Across the globe, enterprise spending on artificial intelligence is surging. We're looking at a $2.5 trillion wave of investment hitting the market. Yet, despite that massive outlay, only about 7% of organizations report that these initiatives are actually improving their bottom line. The rest of the market is stuck. They are caught in a cycle of endless, localized testing that never scales into real operations. 15 isolated pilots spread across different departments might look like progress, but as this pilot theater quadrant shows, high activity often masks a lack of commitment to a single direction. Until an organization connects those local experiments to a broader operational plan, they leave the majority of that transformative value on the table. This stagnation often starts when leadership treats artificial intelligence as a standard software procurement decision. They view it as a simple binary. Do we buy a finished product from a vendor, or do we code our own custom model from scratch? As you can see in the top right quadrant, letting individual departments buy whatever tools they want leads directly to tool sprawl. You get overlapping subscriptions, duplicated costs, and sensitive company data flowing into systems no one properly vetted. On the other hand, trying to custom build everything in-house usually hits a wall. It demands specialized engineering talent that is incredibly expensive and difficult to retain. The correct question isn't whether to buy or build. It's identifying exactly which pieces of the AI portfolio your organization needs to own and which pieces it should acquire. Making that portfolio decision requires evaluating a few distinct factors. The first is strategic differentiation. Using an off-the-shelf AI to summarize meetings or draft emails provides immediate productivity gains. But because your competitors can buy the exact same tool, it creates zero competitive advantage. A custom build only makes economic sense when it leverages your proprietary data to create a capability that rivals cannot replicate. The second factor is regulatory exposure. This acts as the ultimate architectural constraint, often dictating your strategy before engineering even begins. For companies operating in healthcare, finance, or critical infrastructure, new frameworks like the EU AI Act enforce strict legal obligations around human oversight and system traceability. A critical reality here is that purchasing a compliant model from a major vendor does not outsource your legal responsibility. The deployer carries the liability for how that system operates. In regulated environments, compliance demands demonstrable control. Organizations are forced to build their own strict governance layers to monitor inputs and outputs, regardless of where the core model originated. The third factor is data readiness. This is the single most reliable predictor of whether an AI project scales successfully or dies in the testing phase. In most enterprises, data is fragmented. The ERP system doesn't talk to the CRM, the operational records are incomplete, and the formatting is entirely inconsistent. Plugging a sophisticated AI tool into that chaos guarantees failure. A model might look impressive during a highly controlled demo, but it will rapidly underperform when fed messy, structurally incompatible production data. Enterprises must clean and unify their foundational data architecture first. Skipping this step guarantees you will pay to rebuild the entire system later when the initial deployment collapses. The final factor is unit economics. Analyzing costs over a full 12 quarters tells a completely different story than looking at year one. A purchased SaaS AI tool always looks incredibly affordable during a small pilot. But expanding that usage across an entire enterprise beyond the testing phase carries massive financial risk. These platforms rely on usage-based pricing. As more employees use the system and feed larger documents into the context window, your token consumption skyrockets, causing monthly bills to explode unpredictably. This chart tracks cumulative costs. Notice where the blue SaaS line explicitly overtakes the yellow custom build line, accelerating upward. Custom builds require heavy initial investment, but once deployed, maintenance and scaling costs stabilize, shown by the flattened yellow curve. While SaaS appears cheaper in the short term, owned models become significantly more cost-effective at scale when you evaluate them through a full 12-quarter lens. Using these four factors, we organize enterprise AI investments into three distinct categories. If it doesn't change how you compete, choose embedded AI for speed. For targeted departmental gains, bring your own AI requires central coordination. If it genuinely differentiates your business, choose built and blended AI, combining acquired models with proprietary data. This matrix forces leaders to sacrifice control for speed on standard tasks, preserving their engineering capital for the workflows that define their competitive edge. When you do commit to building and blending, you need a rigorous standard for safely moving that complex model into the real world. Consider this implementation scale from aerospace engineering. Look at the blue node for TRL5. It dictates that a system must be tested with real data, real users, and actual security constraints. Enforcing this standard aggressively kills weak or unviable pilot projects early, preventing them from draining massive enterprise resources down the line. The final step is engineering a minimum viable platform. This establishes a foundation with identity management, observability, and compliance guardrails baked in. The most successful enterprises treat artificial intelligence as a rigorously governed portfolio. They align data, investments, and architecture to redesign how the business operates.